Okay guys, so I've been trying to think of the best way to actually, in simple terms, tell you how the architecture of the Prius C, how the hybrid drive system, how the architecture is actually laid out. And I looked at a bunch of different drawings and considered making my own drawing, but I think actually for initial steps, in order to get a world view of the operation of the system, I think actually the energy monitor in the car itself actually affords us the best vehicle for that. So my missus is driving the vehicle. I'm going to be intervening with my pencil to point out a few things on the display here. And so we're just gonna start the vehicle. That doesn't mean start the engine. And this is really strange, man. There's three of us in the vehicle at the moment. All of us are new to the concept of a hybrid drive vehicle. And I'll tell you, it is some weird to wrap your head around when you hit the start. Nothing happens as far as the engine is concerned, potentially, depending on the engine coolant temp, depending on the load. Is the air conditioning system on? There's a number of different scenarios that can transpire. The engine may or may not start. In this scenario, I don't think it will start. So go ahead and power up there, Lisa. So here's the display itself here, guys. As you can see, there is 4 wheels on the display, just for reference purposes. There, the engine just started because of the scenario. Again, it could be the state of charging the battery. It could be a number of things that cause the engine just to start. So just back to where I left off here, our 4 wheels are there for reference. You can see the internal combustion engine itself is actually currently running. You can see that the internal combustion engine is actually providing drive to the motor generator, which is shown on the schematic. There's only one motor generator shown on the schematic, by the way. In reality, there's 2, but there's no need for them to complicate the schematic. They've simplified it by showing just the one, and it will suffice for our purposes. You can see the motor generator is currently charging the high voltage battery, right? It's a 144 volt battery, by the way, guys. I was pretty sure it was 144 volts, but I wanted to wait until I found the actual spec in the manual. So the engine just shut down. Perhaps the battery has achieved its state of charge that it desires, and you can see we're just currently sitting here. So again, we're powered up. We're ready to go. I'm not going to show you the rest of the instrument cluster because I want to stay focused on this. So go ahead and now we'll reverse the driveway here, Lisa. If I was any kind of YouTuber at all, I'd actually have 2 cameras on the go, but I don't know how you edit 2 different shots together, right? So we're actually currently reversing out of my driveway here, guys, and you can see we're operating strictly in electric mode. You can see the high voltage battery is actually providing the energy to the motor generator, obviously operating in motor mode at the moment, providing drive to the front wheels. So we're in drive, and we're just doing a very low speed here. We're only doing about 10 kilometers an hour. That's the torque demand is low enough. Now we're in regeneration mode. We're actually stopping at a stop sign here. So the system is essentially back driving the motor generator. It was operating in generator mode there momentarily to charge the battery. Again, we're asking for torque demand. We're pulling away. We're doing about 20 kilometers at the moment. And again, you can see the battery is actually providing the energy to the motor generator and driving the 2 front wheels in the system. So just pick up speed just a wee touch, Lisa. We're doing 30 kilometers an hour. Again, operating strictly in electric mode here, guys. Yeah, by the way, that statistic up there for you can see the liters per 100. Yeah, that's not even close to being accurate because we've just changed a bunch of the settings and stuff in the system, and it's all reinitializing, right? Again, regeneration when it's in blue there. We're at stop sign. The internal combustion engine shuts off at a stop. It's really weird. You're sitting in a silent car. It is nerve-wracking when you don't know what's going to happen, but clearly it takes a wee bit of getting used to. So we're on a stretch here, guys, where you can see actually if we ask for enough torque, the internal combustion engine and the motor generator itself will actually operate in parallel in order to drive the wheels. And you can see now we're just approaching the limit a wee bit faster. We're doing 60 kilometers an hour at the moment here, guys, a wee bit faster. accelerate a wee bit. Okay, so just lift. Yeah. So you can see, and then you can see when we lift that that we have the internal combustion engine and the wheels actually back driving or driving and back driving the system in order to regenerate. The blue lines there. Go ahead, accelerate, Lisa. So we're accelerating again. The battery feeding the motor generator, the internal combustion operating in parallel. It is not shown on the display here, guys, but clearly there's a gearbox. It's actually a planetary gearbox that actually twins. Let's say that for now. It twins the traction effort from both the internal combustion engine and the motor generator. Again, there's two of them. A wee bit more on that a bit later. But you can see how the system is constantly toggling between the different modes of operation depending on how much torque demand you're actually. We're actually on overdrive here at the moment, guys. We're actually on a downgrade. I know you can't see outside the windows, but we're on a wee bit of a downgrade. Lisa's lifted her foot off the accelerator. Basically, that's why we're actually in regeneration mode at the moment. The battery symbol itself, you kind of expect it when you're not familiar with this. You kind of expect the battery to top up. It never really does that. It actually floats between the central portion of the bar graph, shall we say, for the simple reason that it's constantly managing the state of charge on the battery. It's not really looking to top up the battery. If you think about it, you wouldn't want that because then you'd lose the option to regenerate. So it's constantly managing the state of charge in the battery so that it can optimize its efficiency. It's really quite interesting. We're in eco mode, right? So you can select eco mode. What it does is essentially remap the engine, so you'll get obviously slower acceleration, and it actually alters the rate of cooling that the air conditioning will provide. I think there's a number of things happening in the background when you hit that switch, to be quite honest, but again, we'll expand upon that later. So again, we're just on a wee bit of a rolling section here, guys, so you'll see a transition between just the internal combustion engine when there's more of a torque demand. Put your foot down, Lisa. You can see there when we're asking for more torque, again, the two systems twin in order to drive the wheels. So and you can see again if we're in a cruise mode here, guys, the system with the engine lightly loaded enough, it will put the motor generator into generation mode. As you can see here, we do have a drive and simultaneous charging here. We have drive from the internal combustion engine and charging via the motor generator. So anyway, I hope that made some sense, guys. As I said, I thought this was probably the best way to actually introduce in simplified terms, of course. This is just designed to be a graphic for the driver to simply understand what's happening. But I thought it was a good starting point, right? There's no sense in complicating the issue with the DC to DC converter or the inverter or the multiple motor drive units at the moment and a planetary gearbox. There'll be plenty of time to actually build on the complexity, but just to get an appreciation for the simplified form of the drive, I think this actually does just that. So we'll leave it at that. It's a nice night.